Composite functions. Now we will review composite functions. This involves nested functions, where there is an inner and outer function. The output from the inner function becomes the input for the outer function. The composition of f with g is written in parentheses is one way with f and then this little circle in the middle and g after it in the parentheses, and then x written in another set of parentheses. Or you could write it as f and then g of x in the parentheses of f of x. And no matter which way it is written, either the first way or the second way, it is read as f of g of x. Evaluating composite functions at a given argument is written as f of g of 3. F of g of 3. So again, we have that circle there, and that circle means of for the composite function. And it's worth noting that this is not the same thing as combining functions in operations as we did in the previous topic. Let's try an example of composite functions using real numbers. Here's our example. We are given that f of x is equal to the absolute value of x and g of x is equal to 2x minus 4. We're being asked to evaluate f of g of 1. So we start from the very inside with our input of 1, and we're substituting that into g. So 2 times 1 is 2, minus 4. 2 minus 4 is negative 2. So g of 1 is negative 2. That is the output of g, and it is the new input for f. So now we take this negative 2 and we substitute it in to the absolute value function. And the absolute value of negative 2 is 2. And this demonstrates that f of g of 1 is equal to 2. Let's see why order matters. In example A, we found that f of g of 1 is equal to 2. Now let's actually see what g of f of 1 gives us when we evaluate it. So we're going to start with the inside, and we're going to do f of 1. That's going to be the absolute value of 1, which is 1. And now what we can do is we can then find g of this output value becomes the input for g of x. So we're finding g of 1. So that's 2 times 1 minus 4. That's going to be 2 minus 4, which is negative 2. So as you can see, they showed it in terms of mapping. When you substitute 1 in for f, you get 1. And then you take the 1 and you substitute it in for g, and you end up getting negative 2. And this demonstrates that g of f of 1 is equal to g of 1, which is equal to negative 2. Now, does f of g of 1 equal g of f of 1? Take a moment to pause this video and think about it, and when you're done, unpause it. So we know that g of f of 1 that we just found is equal to negative 2. But we also found that f of g of 1, that was 2 times 1, 2 minus 4, negative 2. And then we took the absolute value of that, and that was positive 2. These two are not equal to one another, which explains why the order matters with composite functions. Let's practice another example where we are evaluating composite functions. We're given the graphs of f and g. We're going to evaluate f of g of 8. So the first thing that we need to do is we need to evaluate g of 8. So if we look at g and we go to the x value of 8, that ends up being 2, or the y coordinate or the function coordinate at that point. So now we are going to evaluate f of 2. So now if we go to 2 and we find it in our function f, it's down here at negative 2. Therefore, f of g of 8 is equal to negative 2. And here is the solution. You could find the solution using function notation. which is how it was originally worked out in this video, or you could also write it in terms of mapping. You could go from 8, go through G, and end up at 2, and then take 2 and go to that x-coordinate on F, and then it produces -2 as the final answer. These first few examples have been with evaluating and going from one function to the next using substitution. But now, if you're just finding the formula for composite functions, you're going to need to work from the inside out. The inner function's output becomes the outer function's input. So to find a formula for f of g of x, the inner function's output g of x is the input for the outer function f, producing the composite f of g of x. In contrast, to find the formula for g of f of x, the inner function's output f of x is the input for the outer function g, producing the composite function g of f of x. Now let's try composing functions without using numerical input. Here's an example. Let f of x be equal to -3 times x plus 10, and g of x be equal to 2 times x minus 4. What is f of g of x? Well, the first step is going to be to take the x value and input it into g, and that will produce g of x, which is 2x minus 4. And now we're going to take 2x minus 4 and we're going to substitute it in for x in our f function. So that's going to be equal to -3 times 2x minus 4 and then plus 10. So we now need to distribute this -3 to both terms. So we'll have -6x plus 12 plus 10, and we can combine our two like terms to get as a final answer -6x plus 22. And here's the solution explained and worked out, and it does match the work that was given when we worked the problem out ourselves, with the final answer being -6 times x plus 22. Let's work through this example algebraically. Let f of x be equal to -3x plus 10, and g of x be equal to 2x minus 4. What is f of g of x? Let's start from the innermost section of our function, which is x, and we're putting x in place of x in g of x. So we end up having g of x being equal to 2x minus 4, and now we have to take f of g of x. That means we're doing f of, and we're putting this entire expression in the parentheses, 2x minus 4, and then we're substituting that entire expression in for x in our f function. So we have -3 times 2x minus 4, and then plus 10. And then we're going to distribute the -3 to both terms. So we have -6x plus 12 plus 10, and then we can combine our like terms to have -6x plus 22 as our final answer for f of g of x. And here's the solution to our problem, and it does demonstrate that f of g of x is equal to 6x plus 22. To write a rule for a composite function, use substitution twice and simplify. Work from the inside out. We are given that f of x is equal to 3x squared plus 2x, and that g of x is 4x. Determine a rule for g of f of x. So we need to first start with f of x. So f of x is equal to 3x squared plus 2x. And now for g, we're finding g of f of x. So this entire thing goes into the parentheses, 3x squared plus 2x. And now we're going to take this entire expression and substitute it in for x and g. So we have 4 times 3x squared plus 2x. And when we distribute the 4 through to both terms, we'll end up getting 12x squared plus 8x as our final answer for g of f of x. And here's the solution to the problem. We first substitute x in for f, wherever x is, so 3x squared plus 2x. And then we take this entire expression and substitute it in for x and g. So we have 4 times 3x squared plus 2x, and when we distribute the 4 to both terms, g of f of x simplifies to become 12x squared plus 8x.